Welcome to your second year of pulp and paper studies. In this short video, I'm going to review a few of the basic concepts that we already covered in your first year. This video will also prepare you for your first assignment. The pulp and paper industry involves three major operations. The first is preparing and getting our raw fibers. And as we've said, one of the major sources we use is wood, and specifically pine and eucalyptus in South Africa, but also recycled fibers from newspapers, cardboard boxes, that kind of thing. We then take these fibers and we, in the pulp mill, separate them to make a pulp, and this pulp we then use in a paper mill to make our final paper products. So in the case of where wood is our raw fiber, the four stages that we have to move through is first the fiber preparation step, and basically that means in the wood yard, if the wood has not been debarked, it has to be debarked. Wood chips has to be made, and then usually there's some sort of sorting and storage operations involved. We will be looking at that. Then the fiber separation stage. This is actually the heart of the process. Can be done either in a mechanical way or a chemical pulping way, and we will be looking at what the differences between those are. Obviously in chemical pulping we use chemicals and we use heat. Then the next step involves some sort of cleaning process, washing and screening, and then lastly we can, it's not always done, whiten the fibers through a bleaching processes. The one process that we haven't spoken about is the so-called recovery process, and in recovery it is about the recovery of chemicals and energy that we get from the chemical pulping process. So in the black liquor we can recover the chemicals and we can use the lignin to generate some energy. Okay, so when we talk about the recycling, the fiber source preparation step is basically a sorting step where we separate, say, newspapers from cardboard boxes. The fiber separation process is basically a slushing process in the presence of chemicals, but note it's not a cooking process, so it's different. Fiber cleaning is a little bit more involved because our fiber sources has ink on it. We need to remove the ink, and there's various processes that we will talk about. And then lastly, usually the fiber whitening stage is more of a case where we modify the chromophores. Remember, chromophores are basically those chemical structures that give color to something. As we've said, we want to separate fibers in wood, and there's basically two ways we can do it. The first way is to use mechanical pulping, and in that process we basically just break the fibers apart, so the lignin is not removed, it stays on the fibers. Or we can use chemical pulping, and in that case we get a delignification, or we actually dissolve the lignin between the fibers, and in that way the fibers can separate. And in terms of chemical pulping, the basic process is we have your raw fiber, your wood chips, you add chemicals, you cook it with those chemicals, and the lignin gets dissolved. There is three processes that's mainly used, types of chemicals. The one just use sodium hydroxide, the so-called Kraft process, which is the main and dominant process in the world today, use sodium hydroxide together with sodium sulfide. And this process we will be discussing in detail. So this is the main bulk of the work of this semester. And then we'll also be looking at sulfite pulping, and you can see the main difference is that the pH at which this chemical works is different from the first two. Okay, let's remind ourselves quickly of a little bit of the chemistry of wood that we've discussed in your S2 course. First of all, we said that the lignin is around the fibers and binds the fibers between the fibers, and that the percentages of the lignin versus the hemicellulose in celluloses is different for hardwoods and softwoods. Remember, hardwoods is eucalyptus trees, softwoods is pine trees. So you can see the cellulose in those two is about the same, and the hemicelluloses and the lignins differ, with lignins being more in the softwoods, i.e. the pine trees. Okay, so the question is, which one of the hardwood or the softwood do you think would be the hardest to cook? And in this course we will try and answer that question. So by the end of this semester you should be able to look and see what wood you think will cook faster. Okay, so in your first assignment also you will have an exercise where you're going to calculate the H factor, and then there's a question on, okay, which wood are you cooking? And you will have to look back at this. You guys can see also here at the top there's a link to a video, so if you click on that it will take you onto the internet, to YouTube, and there's a short video reviewing the whole way that cellulose, hemicelluloses and lignin are combined in wood. From chemistry we know that there's several things that will affect reaction rates, and it is important for us to have some understanding of that, because when we cook our wood chips to remove the lignin, these things will play a role. Okay, so basic chemistry, we know that as the reaction goes on, our reactants will change, the concentration of our reactants will change, and say we use sodium hydroxide as our cooking chemical, you will see there will be a reduction in the concentration of our chemicals, and as we remove the lignin, the amount of lignin that is retained on our wood fibers will change, and we can see that we measure that as a kappa number. Obviously, the concentration of the lignin that is now removed in our cooking liquors, that will have the opposite trend, so that will increase with time. So this is now the lignin in the black liquor. This one, the black one, is the lignin that is still on the fiber. And then finally there is also reactions with our cellulose in our fibers. These cellulose fibers are degraded but not necessarily made soluble, and we can measure this change in the degradation as a change in the viscosity of the pulp. Okay, and you can see the rate at which this happens is different from the rate at which the lignins are removed, and this is important later when we talk about cooking, that obviously we want more of the lignin to be removed and less of the cellulose to be degraded. And remember, we discussed the concept of an H factor. It's the combination of temperature and time, and remember we converted the temperature part to a reaction rate or relative reaction rate, and then as we cook for a certain time the relative reaction rate changes due to the temperature changing, and there's this Arrhenius equation that we can use to convert temperature in kelvins to your reaction rate, or we can just use an equation like this, where we have the temperature in degrees of Celsius at the bottom, and we use the previous equation to calculate your relative reaction rate. So in your assignment 1, I'm going to ask you to calculate a H factor, and you will have to do this conversion between temperature and relative reaction rate. So remember, that was the first step. And then we said that you break your cook into time intervals, say 5 minutes or half an hour, or what the case might be. And for each interval, you then calculate the average reaction rate. You times it by the actual time. Then you get an average H factor for that period, and that all you put together, you get the sum of that. So this is what I want you guys to do for your first assignment. I'm going to give you time intervals and temperatures, and you have to convert it, calculate average for each interval. Remember, we work the time in hours. Your example will give you time in minutes, so you will have to do that, convert to 2 time intervals in hours. Okay, and then, as I've said, softwood and hardwoods tend to cook at different H factors, and you will also have to now figure out which one the assignment asks you to cook. So for which one did you calculate the H factor?